The Milky Way galaxy, our cosmic home, is a vast and intricate system of stars, gas, dust, and dark matter. As one of the billions of galaxies in the observable universe, it offers us a unique vantage point to study galactic structure and dynamics. Classified as a barred spiral galaxy, the Milky Way's architecture is both beautiful and complex. This essay explores the overall shape, structure, and classification of the Milky Way, with a focus on its designation as a barred spiral galaxy. The Milky Way is a disc-shaped galaxy with a diameter of approximately 100,000 light-years and a thickness of about 1,000 light-years in the disk region. Its mass is estimated to be around 1.5 trillion solar masses, most of which is attributed to dark matter. Observations reveal that the Milky Way consists of several distinct structural components: the central bulge, the galactic disk, the spiral arms, the bar, the halo, and the dark matter halo. At the heart of the Milky Way lies the central bulge, a densely packed region of stars, gas, and dust. The bulge is roughly spherical in shape but exhibits a slightly elongated form along its major axis, giving it a peanut-like appearance when viewed edge-on. The bulge is home to a supermassive black hole, Sagittarius A, which has a mass of about 4 million solar masses. Surrounding the black hole are numerous old, metal-rich stars, as well as a population of younger stars formed from gas inflows. The galactic disk is the most recognizable feature of the Milky Way. It is a flat, rotating structure composed of stars, gas, and dust. The disk contains most of the galaxy's luminous stars and is where star formation actively occurs. The disk is further divided into two substructures, the thin disk and the thick disk. The thin disk is younger and contains stars with higher metallicity, while the thick disk is older and populated by stars with lower metallicity. Embedded within the disk are the iconic spiral arms, which are regions of higher density known as density waves. These arms are sites of active star formation, as gravitational compression triggers the collapse of gas clouds. The Milky Way has four primary spiral arms: the Norma arm, the Scutum Centaurus arm, the Sagittarius arm, and the Perseus arm. Additionally, there are minor arms and spurs, such as the Orion arm, where our solar system resides. One of the defining characteristics of the Milky Way is its central bar structure. This elongated feature extends from the center of the galaxy and spans approximately 5,000 to 10,000 light-years. The bar is composed of stars and acts as a channel that funnels gas toward the central bulge, fueling star formation and the growth of the supermassive black hole. Surrounding the disk and bulge is the galactic halo, a roughly spherical region containing old stars, globular clusters, and dark matter. The halo extends far beyond the visible components of the galaxy and is thought to contain a significant portion of the Milky Way's total mass. The stellar halo is sparsely populated compared to the disk, and its stars are primarily ancient and metal-poor. Encasing the visible components of the Milky Way is the dark matter halo, an invisible structure inferred from the galaxy's rotation curve. Dark matter provides the gravitational framework that holds the galaxy together and influences its overall dynamics. The Milky Way is classified as a barred spiral galaxy, designated as type SBC in the Hubble sequence of galaxy morphology. This classification reflects its prominent bar structure and loosely wound spiral arms. Understanding the classification of the Milky Way requires a detailed examination of barred spiral galaxies and their defining characteristics. The Hubble sequence categorizes galaxies based on their appearance. Spiral galaxies are divided into normal spirals and barred spirals, with further subdivisions based on the tightness of the spiral arms and the prominence of the central bulge. The Milky Way's designation as SBC indicates a barred spiral with loosely wound arms and a moderately sized bulge. Bars are common features in spiral galaxies, occurring in about 2/3 of all spirals. They are believed to form through gravitational instabilities in the disk, which redistribute angular momentum and drive gas inward. The Milky Way's bar is relatively strong and has a significant impact on the galaxy's dynamics. It channels gas toward the center, sustaining star formation in the bulge and feeding the supermassive black hole. The Milky Way's spiral arms are not rigid structures, but rather density waves that rotate through the disk. These waves compress gas and dust, triggering star formation. The spiral arms also host a variety of stellar populations, from young, hot, and massive stars to older, cooler stars. The arms are rich in molecular clouds, which serve as nurseries for new stars. The Milky Way's barred spiral structure influences its rotation and overall dynamics. The galaxy exhibits differential rotation, with the inner regions rotating faster than the outer regions. The bar and spiral arms create resonance patterns that shape the motion of stars and gas within the disk. The Milky Way's classification as a barred spiral galaxy places it within the broader context of galactic evolution and diversity. Barred spirals are thought to represent a later stage in the evolution of spiral galaxies, as bars form over time through internal processes and interactions with other galaxies. The Milky Way's structure offers insights into the life cycle of galaxies and the processes that shape them. Studying other barred spiral galaxies, such as NGC 1300 and the Andromeda Galaxy M31, provides valuable comparisons for understanding the Milky Way. While Andromeda is classified as an unbarred spiral, NGC 1300 is a prototypical barred spiral with strikingly similar features to our galaxy. These comparisons highlight the diversity of barred spirals and the shared mechanisms that govern their evolution. The Milky Way's bar and spiral arms play crucial roles in its ongoing evolution. The bar drives gas inflows that sustain star formation, while the spiral arms distribute stars and gas throughout the disk. Interactions with satellite galaxies, such as the Magellanic Clouds, also influence the Milky Way's structure and star formation activity. Studying the Milky Way's structure is challenging because we are located within the galaxy itself. Observational efforts rely on a combination of techniques, including optical, infrared, radio, and X-ray astronomy. Advances in technology and space-based observatories, such as the Gaia mission, have significantly improved our understanding of the galaxy's shape and dynamics. Mapping the Milky Way requires measuring the positions and motions of stars, gas, and other components. Gaia has provided precise data on the positions, distances, and velocities of over 1 billion stars, enabling detailed maps of the galactic disk and halo. Radio observations, such as those from the Very Large Array, VLA, have traced the distribution of neutral hydrogen gas, revealing the spiral arm structure. Because we observe the Milky Way from within, our view is obscured by interstellar dust and gas. Infrared and radio wavelengths are critical for penetrating these obstructions and revealing the galaxy's hidden structure. Despite these challenges, astronomers have pieced together a comprehensive picture of the Milky Way through a combination of observations and theoretical modeling. The Milky Way's structure as a barred spiral galaxy is a testament to the complexity and beauty of the universe. Its central bulge, galactic disk, spiral arms, bar, and halo form an intricate system shaped by gravity, star formation, and cosmic interactions. As our understanding of the Milky Way continues to grow, so too does our appreciation for its role as a cornerstone of modern astrophysics. The classification of the Milky Way as a barred spiral galaxy not only reflects its physical characteristics, but also situates it within the broader narrative of galactic evolution. Through continued observations and theoretical advancements, we deepen our connection to this majestic structure that serves as our cosmic home.